Hello class, welcome to this lesson. During this lesson we're going to talk a little bit about this tool called Web Soil Survey. This is a tool developed by the NRCS, Natural Resource Conservation Service, and it's a soil mapping tool that you can use to get a lot of different information regarding the soil type in any area. The first thing you're going to do is go to Google, type in Web Soil Survey, and you can see here we got Web Soil Survey Home. Go ahead and click that. Make sure you're on the USDA government website. In order to start Web Soil Survey, click this green button, Start Web Soil Survey. And I'll bring this here to the Soil Survey homepage. What we want to do is find an area of interest. This is going to be the property that you're looking at, the area where your house is built, or this property where you want to build a house. And so you can search in many different ways. You can search by state, you can search by longitude, latitude, your section, township, range, or specific address. Here I search by state, and I've already zoomed into my area of interest and where I want to look at this. I've zoomed into just north of Fairbanks, Alaska. I found this area along the Gold Stream Road. There's houses here all over the place, but there's not any houses over here. And so I want that to be my area of interest because as a land purchaser, I'd like to see if there's anything there that'd be worth purchasing. Maybe I want to build a house there or something. And so in order to select your area of interest, you can select either the square or the polygon up here on top. Let's say I'm interested in this whole little section right here. So go ahead and highlight that section that you're interested in. And then the computer's creating your area of interest. So any information that I obtain from this website from here on out is going to be specific to this area. I apologize, sometimes it takes a long time to load. Okay, so there's a variety of things that you can look at. So if we go back to the top here, so you've done your area of interest, you've done that. Next thing you can do is look at your soil map. The soil map is going to tell you the different types of soils that are within your area. The soil types can be broken down mainly because of slope or because of different percentages of texture within the soil. It kind of varies, maybe on a lot of different things, amount of sand, silt, clay, different layers or horizons that we learned about earlier. So in this specific area of interest, we have 3 different soil types, as you can see on the screen. We have the Fairbanks Silt Loam, the Steese-Gilmore Complex, and it breaks it down into percentages and where they are at. So if there are any distinct areas that are different, maybe this area here, 136 designation, the Steese-Gilmore Complex, maybe that has permafrost, whereas this area doesn't. And then I can limit my range in which I want to build my house or buy my property. But let's go ahead and click on one of these soil types. Here we're looking at the Fairbanks Silt Loam. You can do this for all those soil types. It'll tell you the soil profile, the OI, how thick your organic matter is, 0 to 3 inches, how thick your A is or your topsoil, 3 to 30 inches, and your C, which is your almost bedrock material, 30 to 72 inches. So you can go ahead and keep on looking at that information. If you're looking at making a farmland classification is not prime farmland, so maybe you wouldn't want that area if that's what you're into. You can look down here a little bit farther. Depth to restrictive feature. So there's more than 80 inches before you hit a restrictive feature. Sometimes in this area it will designate whether your restrictive features are going to be bedrock or maybe even permafrost. So that's some different things you can look at in this page. Let's just take a quick look at another soil complex. You can print this off if you'd like, or you can simply add it to your shopping cart and save it for later. But the biggest percentage here was this one. We already looked at that. Let's look at the histic, pergolithic psychocleptids. See if this is any different. This one has more of a B horizon, very silt loam, and this one actually does classify a bedrock layer. Look at here, it says depth to restrictive feature 8 to 39 inches to permafrost. So 16 to 72 inches to paralithic bedrock. So you're either going to hit bedrock or permafrost, likely, in this soil type. And that was soil type designation 118. So let's go back to our map here. 118, kind of where these trees are at, that are green. That area there, we know, is probably going to have some permafrost. This area here we looked at, probably not quite so much, but probably some within there. And since you're close to an area of permafrost, you probably really want to do some soil cores and dig just to make sure. So that's kind of what you can see from the Soil Maps tab. We can go ahead and go over to the Soil Data Explorer and explore this a little bit further. So you got different categories here on the left. You can see building site development, construction materials, land classifications, sanitary facilities, soil health, vegetative productivity. We're going to take a look at some of those as examples. Alright, so now we're loaded up. Let's go ahead and look at building site development. So you can go ahead and click and open that. You can look at many different things, dwellings with basements, corrosion of concrete, small commercial buildings. Let's go ahead and look at corrosion of concrete, because I mentioned that in one of our lessons, in that based on the pH or the amount of sulfur in a soil, it can become corrosive to concrete. So we're just going to go ahead and click rating, and it's going to rate each of those soil types that we see in our map. So you can see that the two of the soil types are classified the same since they're both yellow. But this one here at the permafrosty soil is categorized as a red. And we'll see the differences between those here as we scroll down. So the corrosion to concrete scale or rating for the yellow area is moderate, and for the red area is high. So when you if you do end up building some construction or doing anything in that area here, which I probably wouldn't recommend, you probably want to use resistant concrete to corrosion. One of the other things you can kind of look at is sanitary facilities. So here you can look at septic tank absorption fields. Is this an area where you could have a septic tank absorption field? So we'll go ahead and click View Rating. Now it looks like it's a little bit different in that these two here, 136 and 118, are a different rating than the stuff below. So let's go ahead and see what we're looking at here. So the rating is somewhat limited or very limited. The areas in red were very limited to a septic absorption field, whereas the other area was just slightly limited. It's not an ideal place for this. And if you live around the Gold Stream area or in the Fairbanks interior area, you probably know that this area has a lot of dry cabins, and that's probably one of the reasons why. So there's many different things you can explore here. I encourage you just to go on a random place like this, or find an area in which you have a prospective buyer and check it out. So go ahead and let's look at soil properties and qualities, the next tab over, and see what we can learn from this. You can learn a lot about the chemical properties that we just learned from the previous lesson. You can learn about different erosion factors and other soil qualities and features. So let's go ahead and take a look at soil chemical properties. Here you have a lot of things we didn't talk about. This is a little bit more in depth for this course than what we really need to be. But you can look at pH, because we talked a little bit about pH in the previous lessons and what that does for us. So let's go ahead and look at 0 to 12 inches. And I mean, that's pretty much your area of concern when you're talking about gardens or lawns. Let's go ahead and take a look from 0 to 12 inches. And change inches, not centimeters, and click View Rating. So we're looking at this. While this loads, we've got a couple of different variations again in the same area. So the areas that were yellow have pH of 5.8 or 5.7. And the histic soil type, 118 here, is pH of 5. So pH of 5, that's pretty acidic. And chances are you'd have to line that area if you were to try to plant anything, lawn or garden. 5.8 and 5.7 isn't bad. It would be nice to be a little bit closer to 6, but you could probably get away with a couple years of growing things without having to lime. Let's go ahead and check out some erosion factors. How erodible is this soil? So you have wind erodibility index, you have T factor, your K factor, which is your whole soil, or a rock-free K factor. This isn't something that we talked about. Let's go ahead and take a look at it anyway. So how erodible do we want to know? How deep? Let's try 0 to 36 inches. So if you were to do some construction on there, your chances are you'd probably go deeper than 12. Just to see if there's some risk of erosion. Okay, so in this particular area, it's not displayed, that data is not available. But you'd be able to look at that if you'd like. But we can look at other soil properties, such as available water storage, your bulk density, percent organic matter, percent sand, silt, and clay. Let's go ahead and take a look at percent silt. We've talked about that in earlier lessons, how the parameters and qualities, characteristics of sand, silt, and clay are, and what those might indicate for a soil. And so let's go ahead and take a look at that. We'll go 0 to 12 inches again, and click View Rating. Okay, so without looking at the map completely already yet, looks like we have a percent silt of 75% silt and 78.4% silt. In total, 86% of your area is covered in silt. Even though they're slightly distinguished by different categories, it's a high amount of silt. The top 12 inches is going to be highly erodible. They're very fine particles of silt. We talked about this. It may be okay in nutrients. There's probably some clay content in there. There's probably a little bit of sand as well. But as far as siltiness, you can go back down and you can even read about it if you want a little bit more about it. What silt product sizes are, as we mentioned in our lectures, and some other information as well. And lastly, here before we conclude this lesson, let's just take a quick look at percent organic matter. Because organic matter breaks down to help form more soil, and depending on the organic matter, will determine your pH. This area, a lot of needles probably. That's why we have the acidic pH here in this area. Let's go ahead and go to the upper 12 inches also. You know that the organic matter earlier that we looked at was from the organic matter layer was from 0 to 3 inches. But we're just going to get an idea of what's in the whole entire first foot. You might note this little warning sign down here that says soil ratings map may not be valid at this scale. It's probably because I'm zoomed in a little bit too far, but it's still going to give you a good idea of what's going to be happening. Your line borders just might be over a little bit. We can always zoom out and look at that a little bit more closely. So the Fairbanks silt loam has 26.93% organic matter, 90% organic matter in the area that has permafrost. That looks like it's a lot covered in a lot more needly trees. And the Steve Gilmore complex has 17.7% organic matter. Organic matter in the Fairbanks interior area, we've seen anywhere from maybe 5 to 26% organic matter in our soil samples that we've been taking here for gardens and lawns. So 90% seems like it's an awful lot. Maybe some peat is involved in that area, although it looks like it's pretty wooded. So you get an idea of what kind of organic matter you'd be working with. And if you want to learn a little bit more about organic matter, here's a definition of what it is. Organic matter content in the soil can be maintained by returning crop residue to the soil. You have so much organic matter here that you wouldn't have to ever worry about that unless you start exhausting the soil. So there's just some different things you can see from using web soil survey. You can decide and learn how deep the soil is before you hit a restriction layer, whether it be bedrock or permafrost. You can see the percent sandstone clay, and we've learned about the characteristics of those. You can learn about different vegetation that you can see in the area, what would grow well, based on some of these categories we've seen in the suitabilities and limitations for use. But the important things are, restriction for construction. You'd be able to look at available water storage and capacity. Depth to water table is also something you'd be able to look at. Over here in the physical properties, you probably get an idea of how deep you might have to go before you have to dig a well, how deep your well might have to be. Yeah, so I think that's kind of a quick overview of web soil survey, and hopefully you'll be able to utilize this and kind of figure out which areas that you're selling or trying to convince landowners to purchase or buy houses on, that you can give them an idea of what the risks might be, or give them an idea of yeah, there's probably not permafrost here. You can really follow up with your clientele and give them good quality information. See you next lesson.